Hey Chaparral ChemCom students, this is Mr. Eder here. You may be in Mr. Johnson's class as well, but this is still going to be a good video for you to understand this density of a penny lab. At the beginning, when you scroll down, you'll see an introduction. Make sure you watch the video, click play, watch the video. It goes through a few different things, and answer this question to submit your answer. You will then open up part 1, and in part 1 you are collecting data for different pennies. Notice that the volume of water starts at 20 milliliters, so you will need to subtract that volume to get the volume of the pennies. That's called water displacement. You just want the volume of the penny, not the volume of the water. When you click play, you will see that they drop pennies in. Pause the video, and when you pause the video, there's 5 pennies, the mass is 12.51 grams, and notice the volume of water has gone up almost 2 milliliters, so you would record the volume as the volume of the pennies of about 22 milliliters, minus 20 milliliters of water would be 2 milliliters of volume for the pennies. You will do this for 5 trials, right? There's many more trials here with more pennies. As we play ahead, there's more pennies, the more volume. Answer these questions. The main thing I want to show you here is the data table. You can type in the name here. So it says make columns for these 4 things. So make a column for number of pennies. That would be 5, 10, 15, 20, so on. Mass of pennies is the next column, and that's the mass that you record off of the balance. That's data that you need to write down. But then it says volume of pennies, so make sure you add a new column. So click here, insert column to the right, volume of pennies. And then it says density of pennies. So click here, insert another column to the right, density of pennies. I'm just going to make up some values here. These are not your values, but let's say the mass of the pennies is 5 grams. Okay, so we want to include our units of grams here, milliliters here, and grams per milliliter. And let's say the volume is 1 milliliter. And then we have 10 grams, and let's say the volume is 2 milliliters. So again, I'm just making up data here. Maybe this is 15 grams. And this is 3 milliliters. Again, this is the data that you recorded from the video above. To calculate density, remember density is grams per milliliter. There's a couple different ways you could do that. One way is to have it calculate it for you, and you want to insert column setting or a column formula. And so it's mass of pennies and then divided by the volume of pennies. And when you submit, it automatically calculates that for you. You then graph. We want to put the mass on the y-axis. So put mass of pennies. We want to put volume on the x-axis. So we go volume of pennies. When you click done, notice there's 3 data points here. Those are the data points that you wrote down here. You also want to insert a curve fit, so click on curve fits, and this should be linear. So find the linear option, y equals ax plus b. This is just like y equals mx plus b. When we click done, we get a slope and a y-intercept. There's a few more questions here. Okay, figure out what your slope value is. That would be a, this number here. So not 5. But your data should be closer to either 7, 9, 1, greater than 10, or less than 1, or negative. Okay, check the one that fits your data the best. You will then figure out what substance these pennies are made of. Another question, and then go on to part 2. Now in part 2, you're collecting data for a different set of pennies. Make sure, again, you're writing down the volume and the mass of the pennies. Make the same 4 data columns. Make the graph again with mass on the y-axis, volume on the x-axis, and tell me what this second set of pennies is made out of. When you finish that, you are all done with the lab. Let your instructor know if you have any questions. Thank you.